All right. I just finished filming adding and subtracting numbers in scientific notation part. So it's time for the part 2 video. I'm going to get started. I'm enjoying this teaching from home. Clearly, I don't have to get all dressed up. I can just kind of be comfortable. In fact, I didn't even shower or brush my teeth, so I smell really bad. But you don't know that, and that's what makes this really great. Anyway, into the important stuff. We are going to be adding and subtracting numbers in scientific notation part 2. Just to recap, in part 1, all the problems we did, the base 10 had the same exponent, so it made it really, really easy. So before we get into how to do some of these problems, I wrote down some rules for adding and subtracting numbers in scientific notation. This might be a good spot to pause and copy some of this stuff down as I set up my phone. I also put my phone on Do Not Disturb, so if I get text messages or emails, it won't vibrate and shake the screen. Sorry about that in the part 1 video. So anyway, when we are adding and subtracting numbers in scientific notation, we talked about in the part 1 video, you have to have the same or common exponent over your base 10. All right, so we'll talk about that when we get to examples a little bit, and we talked about that a lot in the part 1 video. Once you have that, you can just go right ahead and add or subtract your coefficients, add or subtract the numbers, those decimals, whatever, that are right in the front part of the numbers in scientific notation. And this last part is going to be important because we did it at the end of some problems in the part 1 video, and we're actually going to have to do it to start some of the problems in the part 2 video. You'll see what I mean in a second, but you need to rewrite your answer when needed. Your coefficient must be between 1 and 10. So as you can see, even though we're kind of self-quarantining, my handwriting has not gotten any better. So if you can't read what some of this says, bottom line is you might have to change the exponent in some of these numbers, and when you do that, you kind of got to balance it out. So if you do something and you make your coefficient bigger, well, then the exponent has to get smaller to balance it out, and vice versa. If you do something and you make your coefficient smaller, then you got to make your exponent bigger. You kind of got to balance it out. You're really moving powers of 10 back and forth by moving the decimal point. You're removing or adding powers of 10, so you got to change the exponent accordingly. So like I said, these are some good things to write down if you can read my handwriting. Like I said in the other video, send me suggestions, send me questions, emails. I'm going to try to be active on that new Google Classroom. Send me as much as you want. Looking into doing new and different things to try to interact with you guys and keep you guys up to speed. If you're a Core B student, I told you there's going to be a video coming soon about simplifying radicals, but that exponent test does have some scientific notation stuff on it, so it might be worth staying in and watching this one, especially if you just miss me or miss the sound of my voice. So hopefully you wrote all that down. If not, pause it right now and go ahead and write it down. I'm going to erase it and do our first problem. Again, special thanks to my kiddos for letting me use their board. All right, so here we go. First problem we're going to look at today, and this is the part 2 video, so you know these are going to be harder than the ones we saw the other day. We're going to talk in the trillions. So I'm talking 4.2 trillion, but instead of writing out all those zeros, I'm just going to write that in scientific notation. So that's 4.2 times 10 to the 12th. Now I'm going to add that to 63 trillion, which is 6.3 times 10 to the 13th. So these are huge numbers, but using scientific notation, I'm going to have to write out all the zeros, and it's actually going to make adding and subtracting them even easier. So if you can't read that, I'm going to rewrite that because it doesn't look great on the screen. That's a 13. So I have a 12 here, and I have a 13 here. So in the first video, all the problems we did were really easy because you already had that same common exponent. I don't have that this time around. All right, I have this is 10 to the 12th. This is 10 to the 13th. But if I can make this a 12 and this a 12, that's going to be really easy. Or if I can make this a 13 and keep this at 13, that's going to be really easy. It's going to be just like the videos we did in part 1. So that's exactly what we're going to do. So instead of rewriting the numbers in proper scientific notation in the end, we might have to rewrite some of these numbers, take them out of proper scientific notation, which is okay as long as my final answer is in proper scientific notation. So right now for this problem, what I'm going to do is I want to make these both 13. So I'm going to cross out this 12 and I'm going to make it a 13. This number over here, I'm going to keep as 6.3 times 10 to the 13th because I just want both my problems to have a 10 to the 13th in it. Now, I can't just simply change this to 10 to the 13th and be on my merry way. If I'm changing the exponent, I need to change the coefficient accordingly. So in those notes that I just erased, it kind of said, if one gets bigger, the other gets smaller. If one gets smaller, the other gets bigger. Here, I need an extra power of 10. If I'm making this from 12 to 13, I'm adding an extra 10 here. Instead of 12 tens, there are now 13 tens. Where am I going to get that extra 10 from? I'm going to take it out of here. I'm going to divide this by 10, meaning that I'm going to have to make this smaller. Do-de-do. I'm going to move my decimal point this way because that's going to make it smaller. If I would have went the other way, that would have became 42. This would have been bigger, and this would have been bigger. That can't happen. I got to keep it balanced. So I'm going to move my decimal point that way and make this 0.42. So now I have 0.42 times 10 to the 13th. I have 6.3 times 10 to the 13th. I know this is not in proper scientific notation. That's okay. This is not my answer. I'm just using this to help me get to my answer. I'm going to go off on the side now. I'm going to do some decimal addition because this one is an addition problem. Lining up my decimal points like the buttons on my shirt, even though I'm not wearing a button-down shirt today, which is nice. 2 plus 0 is 2. 3 plus 4 is 7. Bring down your decimal point. I'm going to get a 6 there. So my final answer is going to be 6.72 times 10 to the 13th. So there we go. That is going to go and be my final answer. It's in proper scientific notation. I have something between 1 and 10. It's not that much harder than the problems we did before. There's just going to be that one extra step you're going to have to do in the beginning, because remember, the key to this whole problem is making sure that you have the same exponent here and here. Once you got that, you are good to go, and you can just add and subtract your coefficients. So now I'm going to rewind without actually rewinding. I'm just going to go back to this original problem here, because I'm sure there's some people thinking at home, you said they could both be 12, you could both be 13. So what's that going to look like if I want to keep this a 12 and maybe I want to change the 13 to a 12? And you could have done that. So again, first I had 6.3. So now if I want to make these both 12, this would stay 4.2 times 10 to the 12th. All right, this is now changing to 10 to the 12th power, but that means I have to change this somehow. So now, really what I'm doing is there was 13 tens here. Now there's only 12 tens. So what am I doing with that extra 10 that I took away from here? I'm going to multiply this by that extra 10. So instead of 6.3, it's going to become 6.3 times 10 is going to be 63. All right. So I made that bigger because, again, from 13 to 12, my exponent got smaller. That means my coefficient is going to get bigger. Now I can go ahead and add 63 with 4.2. I'm going to get 67.2 times 10 to the 12th. But we talked about this in the part 1 video. That is going to be too big. My coefficient is too big. I need to rewrite my final answer, so I have to do one minor extra step here. I'm going to want to put my decimal point there to make this 6.72. If I'm doing that, 67.2, 6.72, I've made my coefficient smaller, which means my exponent has to get bigger. Just like before, I get this as my final answer. So bottom line being that it doesn't matter which one you change it to, as long as you change them to both the same thing, you'll get the same answer in the end of it. All right, let's do another example. Again, if I'm going too fast, you want to rewatch something, see how I did it. Maybe you're daydreaming. Maybe you look down on your phone while I did something. You're not sure how I did it. Pause this video, rewind it, and go back and watch it again. So let's do an easy one. Let's do 5 times 10 to the 8th. And we're going to subtract 6 times 10 to the 6th. All right. So not crazy numbers, but again, I got an 8 here, I got a 6 here. It's not the same number. I got to make them the same. So again, we just talked about it. It doesn't really matter. I can make them both 8. I can make them both 6. So I'm going to make them both 6 for this part. So now if I make this 6, 8 becomes a 6. So this clearly got smaller. This has to get bigger. But now I made this smaller by 2. 8 to 6 is a change of 2. That means I need to make the 5 bigger by 2 decimal places. So instead of 5, it's going to be doop-de-doo, doop-de-doo. It's going to be 500 times 10 to the 6th. We want to keep this the same, so that's going to be 6 times 10 to the 6th. And now I subtract 500 minus 6. That's going to be 496. 94. 494 times 10 to the 6th. So that's my answer, but that is not in proper scientific notation. So I'm going to want to take the decimal point that's right there at the moment and move it there, because 4.94, that is between 1 and 10. Now my coefficient is in proper scientific notation. But again, if I move this 2 spots to make 494 smaller, I did 2 moves to make it smaller. That means I need to make my exponent bigger by 2. So that's going to be my final answer there in that subtraction problem. So I need to get that common exponent. To get my common exponent, I'm changing things by more than 1, by 2, by 3, by 4. Then I need to move the decimal point in the coefficient by 2 or 3 by 4 to keep everything balanced. Whatever I'm doing, I need to keep it balanced. That's a big thing in adding and subtracting numbers in scientific notation, is keeping things balanced. All right, so I'm going to go back to that original problem just really quickly. I do want to keep these videos short. I feel like this one's going to run a little bit long because it's a little bit more complicated. Just to show you, if I wanted to keep the 8, what that problem would have looked like. So I keep that as 8. I cross out the 6 and make that an 8. So now if I did the problem that way, this would be 5 times 10 to the 8th. But now this is getting bigger by 2. That means this has to get smaller by 2. So that's going to be 2 decimal moves, and it's going to be 0.06 times 10 to the 8th. So now when I do my subtraction, it's going to be 5 minus 0.06. I get that same answer I got before, 4.94 times 10 to the 8th. So I can do it that way too. I did that fast. I was a little distracted because my dog came over halfway through that problem. She sees someone out the window. Shay, say hi to North Haven Middle School. Yeah. Can I do one more problem with them? You gonna be okay? Okay. All right, so I'm gonna do one more problem. Hopefully that made sense. I know I got a little distracted because of Shay Girl here. But let's do... All right, last problem of the day, last problem of this video, because I'm going to make more videos today. But I got 8.6 times 10 to the negative 6. So those negative exponents, always tricky. Realize that represents a really, really small decimal. And we're going to subtract 7.52 times 10 to the negative 8. All right, so this is going to be a little bit trickier of a problem. I'm going to make them both negative 8. That's what I'm going to go with. I'm going to make them both negative 8. So that means I'm going to keep this guy as 7.52 times 10 to the negative 8. This is going to change to negative 8. So now with negatives, I'm telling you right now, take an extra 20 seconds to really think about this. All right, I went from negative 6 to negative 8. Did I get smaller or did I get bigger? You've actually made your exponent smaller, because negative 6 to negative 8 is smaller. So if this got smaller by 2, I need to make this bigger by 2 decimal moves. So I got to go doop-de-doo, doop-de-doo. So that's going to become 860. And that is the subtraction that we're going to do. So now this is going to be 860 minus 7.52. This video is running a little long, so to save time, I'm going to show you that that comes out to 852.48 times 10 to the negative 8. But again, my final answer is now not in proper scientific notation form. So I got to move my decimal point over places. I get 8.5248. It was 2 moves to become smaller. So I'm going to make -8 bigger by 2. So if -8 is bigger by 2, it turns to -6. All right, and real quick side note here, because I know this video is going long and I hope I didn't lose your interest. Hopefully Shay Girl kept you in there. If I change these both to -6, I'd have 8.6 times 10 to the -6 minus, if I turn this to -6 times 10 to the -6, that's getting bigger by 2. This would have to get smaller by 2. So it actually turned to 0.0752 because I'm moving the decimal point 2 spots. And when I subtract that, I'm actually going to get that same answer as before. So again, it doesn't matter. I know I did those problems a little bit fast, but the bottom line to remember here is that I just need a common exponent. It doesn't matter which one I pick. Negatives are a little bit trickier because you have to remember, if you're making an exponent bigger, the coefficient has to get smaller. If you're making the exponent smaller, the coefficient has to get bigger. So when negatives are involved, take an extra couple of minutes and really think about what is going on there. All right, I'm going to leave you with a props to the tops question. Email me your answer. Tell me what you got. Here is the props to the tops question. I'll give you 2 of them. All right, 0.071 plus 6 times 10 to the -2nd, and 30, those are 2 separate problems, so 32,000 minus 2.1 times 10 to the 4th. All right, so those are 2 props to the tops questions for you. Try them out. 1 number written in standard notation, 1 number written in scientific notation. So turn them both to standard and go do the math, or turn them both to scientific and do the math. That's up to you. That's your call. All right, this video went over 15 minutes. I told you I was going to keep them under 15 minutes, so sorry about that. I know I did some things pretty fast there. This is probably the hardest thing to do with scientific notation. I think converting back and forth is pretty easy. We did that before break. If you need a refresher, I'll do one. Multiplying and dividing in scientific notation isn't too bad. It's when you have to add and subtract when the numbers have different exponents that is the trickiest thing. All right, I hope you guys are doing well. Again, please feel free to reach out, email me with any questions. All right, we're going to get through this all together, and hopefully you're staying safe, staying inside. Like I said, binging some great shows. Give me some show suggestions. My suggestion for you is if you have Hulu, find Scrubs. It's a great show. Definitely go and watch Scrubs. There's plenty of garbage out there, but Scrubs is a good show. All right, that's it. I've gone over the time. Have a great day.